Assalamu alaikum. In this lecture, we're going to discuss about some difference operators that we're going to use as far as our interpolation and numerical differentiation and integration formula is concerned. So we're going to discuss about the different, you can say, definition of the different difference operators, their working, and their functions as far as the numerical methods are concerned, and using these definitions or symbols for that difference operator, we're going to use it for interpolation in our coming lectures, and in numerical differentiation and integration as well. So for example, consider y as a f of x function. That is a given function here, and h is any fixed value here. Then x will be equal to x naught, x1 and x2, so on xn, such that then the whole this x that is defined in this function will gonna be written like this, or gonna be defined like this, that x1 will be equal to x naught plus h, x2 will be x1 plus h. And remember, this h is the fixed length. Okay, so whenever we're gonna add this length to our previous value, we will get another value, and this h will be having a fixed value whenever we're gonna add it into the function. Okay, and it's gonna provide us the next value as for our fx function is concerned. Similarly, x3 will be equal to x2 plus h2, or it will be equal to x naught plus 3h as well. So because h is having a same length, so when we want to get a value of x3, we're gonna put like x2 plus h2, or we get from by putting a value of x naught plus 3h here. And when we want to find the value of xn, that will be equal to xn plus xn minus 1 plus h here. Okay, and that will be also equal to, when we're gonna do like this, xn also equal to x naught plus nh here. So whenever we're gonna use interpolation in our coming lectures, we're gonna use this h as a fixed length, and from that fixed length we're gonna define the values of x as our in our fx function. Now using that definition of the fixed length and the values of the x in our fx function, we're going to define y naught in terms of function f of x like this, that y naught will be equal to f of x naught, then y1 will be equal to f of x1, and y2 will be equal to f of x2, and same when we want to find yn, that will be equal to the f into xn. Okay, so these are all the things that you have to remember as far as our interpolation formulae are concerned. Note that h is called the length of interval, and all xi are that we are defining here, like x naught, x1, x2, and so on xn. These are all equidistant. Okay, they are having the same distance between them. Now I want to define some shifting operators that we're going to use in our coming lectures. First, I'm going to define a shifting operator that is going to be represented with symbol e. Remember, this is called a shifting operator as far as in our numerical methods are concerned, and that is called this is going to be represented with symbol e, and it's going to be defined like this. Whenever we're going to implement a shifting operator on any f of x function, it will gonna give us the value of f x plus h. Remember, this h we have defined earlier, that is the length, that is the fixed length that we were talking about earlier. And when we want to add e square, you can say the shifting operator square into our function f of x, that will gonna give us fx plus 2h, or it can be written like e into f of x. When we're gonna write like this, we're gonna write like this very well, that will be equal to e into fx plus h, and that will gonna be like fx plus 2h. Okay, first this one, e into f of x value, and then e into this function, so that will be equal to f of x plus 2h. Now moving further, I'm going to define some other operations as far as this shifting operator is concerned. whenever we want to have an inverse of this shifting operator and we want to implement on f of x function, that will gonna give us fx minus h. Okay, and when we want to have e minus 2 in, and we want to implement e minus 2 into e raised to the power minus 2 into f of x function, that will gonna give us f into x minus 2h. Okay, and when we're gonna have e raised to the power 1 by 2 and we want to implement this on function f of x, that will gonna provide us fx plus h of f, half of the length. Okay, f of x plus half of the length h by 2 here. Okay, and remember, again we want to define this shifting operator in terms of our y parameter as well. Now from the previous definition, e y naught will be equal to e f of x of naught, and that e f x naught will be equal to e f x naught plus h. Remember this shifting operator from the definition of this shifting operator, when we are applying e into f of x, that will that we're providing us f of x plus h. So if we have e into f of x naught, that's going to provide us f into x naught plus h. And from this you see here, because this is x naught plus h, they are x naught plus h is equal to x of 1, so that will be equal to f of x1, and f of x1 will be equal to y1 here. Okay, and e y1 is equal to y2 as well. Okay, so and e inverse y1 is equal to y naught. Okay, this is the backward shifting, and this is the forward shifting as far as this shifting operator is concerned. Now we're going to move on to another operator that is called forward difference operator, that is going to be represented with this symbol. Okay, and that is defined as, when you're going to apply forward difference operator to function f of x, that will be equal to f of x plus h minus f of x. Okay, and when we're going to have the square of this forward difference operator and we want to apply this on our function, that will gonna be written like this: forward difference operator del into del f of x. Then this is gonna be written like this, because here we know from the previous definition that here from this definition, that will be equal to fx plus h minus f of x. So, and now from this you see that will be equal, this will be equal to, from the you say definition of forward difference operator, that will be equal to del into f of x plus h minus del f of x here. Okay, now see here, this will be equal to fx plus 2h. Okay, and minus fx plus h minus fx plus h minus f of x. So that will be our resultant function value as far as this operator is concerned. Now moving further, we will gonna discuss how, if this operator, you can say this if you want to apply this operator, you can say this forward difference operator to our function f of x. Now we are taking this operator as a square and we are implementing on our f of x function, that will be equal to fx plus 2h minus 2 into f of x plus h plus f of x. And when we want to apply it on our y function, y value, y parameter, that will be equal to forward difference operator. When we're going to apply it onto y naught value, that will gonna give us a del into f of x naught, and that will be equal to f of x naught plus h minus f of x naught. Okay, now, and that you know from earlier on, that will be equal to f of x1, and that is equal to f of x naught. Okay, now if we want to apply, you see from here that this, if going to be implement like del y naught, that will be equal to y1 minus y naught, del y1 will be equal to y2 minus y1, del y2 will be equal to y3 minus y2. Okay, and del square y naught will be equal to del into del y naught and del y1 minus y naught. Okay, so this is all about the difference, you can say, of difference of the implementation of the difference operators as far as forward difference operator is concerned. Now we have another difference operator, that is called a back difference operator, that is gonna be represented with this symbol. Okay, remember these all operator we're going to use in interpolation when we want to define the tables as far as central difference table is concerned, or backward difference table is concerned, or forward difference table is concerned. Now this backward difference operator, when we want to implement our function f of x, that will gonna give us the function value minus fx minus h, and when we want to apply it on y1 value, it will give us when we want to apply it y1, remember from the previous definition that y1 is equal to f of x1, then it will gonna give us fx1 minus fx1 minus h. Okay, so and from this here you see f of x1 minus f of x naught plus h minus h here. This x1 is basically x naught plus h. Now from there you see f of x1 minus f of x naught, where h will gonna be cancelled with h. Okay, so now here you see when we have this backward difference operator that we apply on y1 value, it will give you y1 minus y naught. When it is applied on y2, it will give you y2 minus y1, and so on. Okay, and one thing I want to show you here, that when we are going to apply it in terms of a square to y2 value, it will give you like this value, and that's going to be written like this one, and then finally it will going to be have this. So you have to remember all these values whenever we're gonna have, you can say, define the central difference tables, or you can say the forward difference tables or the backward difference tables when we're going to use it in interpolation. There is another difference operator as well, as far as these difference operators are concerned, but we're not going to use that much, but I want to define like these two. I want to define these two operators as well. First one is called central difference operator, that will be going to represent it with symbol this one epsilon. So you can say this symbol delta, and define as when we're going to apply this delta to an f of x function, it will give you f of x plus h2 minus f x x minus h2, where h is the fixed length here. And there is another operator that is called Avenier operator, that is going to be represented with symbol mu, and define as mu. When we're going to apply it on a function of f of x, it will going to give you 1 over 2 f of x plus f of x minus h2 minus f of x minus h2. Okay, this is f of x plus h2 minus f of x minus h2. So this is all about the difference operators. Please remember that these all operators, these all definitions, we're going to use it in our next lecture. We're going to define the different tables in our interpolation. So so far, thank you so much.